Hello everyone, today we will be looking at Module 5 Synchronous Generator. Contents to be covered: Synchronous Generator Introduction, Construction of Stator Rotor, Frequency of the Induced EMF. Synchronous Generator. Any electrical machine which generates three-phase voltage is called alternator. An alternator is also known as synchronous generator. So the basic difference between the generator and the alternator is that both are electrical machine which takes the input as mechanical energy and give the output as electrical energy. But in case of generator, it converts that mechanical energy to electrical energy into AC or DC. But in case of alternator, it converts mechanical energy to electrical energy into AC only. So generator can be used as AC generator. It can be also used as an DC generator. But alternator is meant for generating AC only. Now, both generator and the alternator works on the principle of electromagnetic induction. So, in order to understand the phenomena or the principle behind Faraday's law of electromagnetic induction, we need to know what it states. So whenever a conductor is moved in magnetic field such that it cut across the lines of flux, an EMF is induced in the conductor. So you take two monopoles, north and south. In between those two poles, if you are trying to move a conductor, there is an EMF induced in the conductor. So for the generation of EMF, there should be a relative motion between the conductor and the magnetic field, keeping any of them as constant. If you try to look at the phenomena of EMI, here there is a coil to which we are connecting a galvanometer, and we are taking one permanent magnet. Now both are stationary. Now I'll try to take the permanent magnet and move towards the coil. So there is a deflection observed in the galvanometer, saying that there is an EMF induced. Once the magnet is moved away from the galvanometer, again there is a deflection observed, but that will be in opposite direction. So movement of magnet towards and away from the coil is going to induce some EMF. So here the magnet is moving, the coil is stationary, right? Or now I'll keep the magnet stationary and I'll move the coil towards the magnet. So when I move the coil towards the magnet, there is an EMF induced in the coil. There is a deflection observed. But when I move away from the magnet, there is a deflection observed, but it will be in opposite direction. Right? So in order to generate an EMF, there should be a relative motion between the magnet and the coil, keeping any of them as a constant. So we are going to keep the coil constant and we are going to move the magnet in case of an alternator. Why? Because alternator consists of two parts, stator and rotor. Stator is what? It has stationary part. It is a stationary part. Rotor is rotatory part. Stator is made up of cylindrical in shape. It is in cylindrical shape, made up of steel or cast steel, you can say. It has uniform slots on its inner periphery, and in these slots you are going to place the stator conductors, either in star or delta fashion. Whereas a rotor is going to rotate inside the stator, and to the rotor you are going to wound some coils to which you are going to supply DC, so that you can generate constant magnetic field, wherein the rotor will act as a electromagnet. Right. So here the stator conductors, the stator, in that you have slots. In that slot you are going to place the stator conductors which are stationary. It is acting as a coil now. Now the rotor, it is acting like an electromagnet, so it is rotating. Okay. So let's look at the construction of an alternator. Alternator consists of two parts, stator and rotor. Here the stator part is stationary and the rotor part is rotatory. The key terms for stator are stationary armature conductor, which can be also called as armature winding. Rotor, field system. In field system you have poles and field winding. The field winding are nothing but your copper wires. Now there are few advantages wherein the field system is rotating and the armature is stationary. The voltage developed is directly connected to the load. So whatever the voltage is produced or developed in the alternator, which can be observed in the stator conductors, can be easily tapped out or easily can be given to the load. It is easy to insulate the stationary armature for high AC generated voltages. The armature conductors can be easily fixed in the slots to prevent its displacement. Stator. Again, stator is a stationary part, right? Now the stator has lifting eye, a stator frame, a base plate. You have stator core. In the stator core you have uniform slots. So it consists of a stator frame, which is the outermost cover of the machine, which is made up of mild steel plates which are welded together to form a cylindrical drum. Right. Now the stator frame encloses a hollow cylindrical drum. Right. In that cylindrical drum you have stator core made up of thin laminations of silicon steel to reduce the eddy current losses. On the inner periphery of the stator core, uniform slots are cut and the stator conductors are placed in these stator slots, either in star or delta fashion. Right. Ducts are provided on the stator frame. So stator frame is the outermost cover. On the stator frame you have some ducts for ventilation purpose, which circulates the free air and helps in cooling the alternator. I hope looking at the picture the construction is understood to you. Next, this is the explanation part. You can refer. We'll look at what is rotor. There are two types of rotor: salient pole and non-salient pole, which is also called as smooth cylindrical type. Now here in salient pole type rotor, as I said, the rotor is going to rotate in a stator. Right. Stator is having stator frame. It is having stator core. In that stator core you have its periphery. You will have slots, and in these slots you are going to place stator conductors. Again, it is a hollow. In that hollow you are going to place the rotor now. So this is your rotor. So basically the rotor core is cylindrical in shape and it is made up of cast steel, and these type of rotors are suitable for low and moderate speed operation of 300 rpm to 600 rpm. It has large projected poles. Which are fixed by the means of nuts and bolts to the heavy magnetic field. So these are the large projected poles which are fixed to the wheel by the means of nuts and bolts. Such rotor will have a large diameter and short axial length. Now the poles are laminated to reduce the eddy current losses. Now on these poles, a field coil is wounded, to which a DC voltage source is applied to generate magnetic field. Thereby, the poles becomes an electromagnet. If you stop supplying DC field, some small amount of flux will be remained in the pole, but it is not sufficient to induce an EMF in the stator conductors. In fact, there will be small amount of EMF also induced, which is not appropriate, right? So, silent pole, it is characterized by a large diameter and short axial length. It is suitable for low and moderate speed. It has large number of projected poles, which are fixed by the means of nuts and bolts to heavy magnetic field made up of cast iron or steel. Field coils are wound on the poles, to which DC voltage source is applied to generate magnetic field, and the poles become an electromagnet. I hope the construction is understood to you. So this is the explanation. We'll go with the next one, non-salient pole type of rotor. Right. So again, the rotor core is cylindrical in structure, made up of cast steel. It is suitable for high speed operation, whereas salient pole is suitable for low and medium speed operation. But non-salient pole is suitable for high speed operation of 1500 rpm to 3000 rpm. They do not have large projected poles. The cylindrical core itself is having number of slots on its outer periphery. The core is having number of slots on its outer periphery to place the field windings, and the unslotted portion of the cylinder. So the unslotted portion of the cylinder itself will act as a pole, right? Again to the field windings which are placed in these slots are excited by DC voltage source to generate a constant magnetic field. As simple as it is. So here, construction of alternator is very important. You need to explain both stator and rotor with the diagram, and even they may ask you only explain rotor and its type. So the diagram plus the explanation is very important. So this is the explanation. We look at the next topic, which is frequency of the induced EMF. What will be the frequency of the induced EMF? As I said, in India the frequency is 50 Hz. In other countries it is 60 Hz. Whichever kind of machine you're using, or whatever kind of machine or appliance you're using at home, will be having a frequency of 50 Hz AC. Okay. Now you have a single slot, and in this single slot you have one single conductor. You have a rotor with two alternate poles, north and south, which is rotating in clockwise direction with angular velocity omega. Now, whenever the north pole pass across the conductor which is placed in the slot, a positive half cycle of EMF is induced in the conductor. And when the south pole sweep across the conductor, a negative half cycle of the EMF is induced in the conductor. This should be south pole. Okay. So positive half cycle of the EMF is induced obtained by north pole. Negative half cycle of the EMF is induced in the conductor is obtained by south pole. So you get one complete cycle by two monopoles, that is north and south pole, right? Hence, one cycle of EMF is induced in the conductor. One cycle of EMF is induced in the conductor when one pair of north and south sweep across it. So by sweeping of north and south pole, we are getting one complete cycle. Now, how many number of cycles of EMF are induced in one revolution? So in one cycle we have two half cycles, one is positive and negative. So both positive and negative are obtained by north and south pole. Therefore it is P by 2. P represents the pole. Next, number of revolution per second. So what is the revolution of that particular wheel in second? So it is N by 60, which is where N represents the speed in RPM. Therefore, frequency of the induced EMF is given by the number of cycles per second. Number of cycles of EMF induced per revolution into number of revolutions per second. So number of cycles of EMF induced is P by 2. Number of revolution per second is N by 60. So the answer would be Pn by 120 Hertz, where P represents the pole and represents the speed of the rotor in RPM. So this part is very important to understand the next topic, that is the derivation on EMF equation of alternator. So please go through this video and try to understand. So the construction of alternator, stator rotor, its explanation diagram is very important for your main exam. For the next class we'll discuss with derivation on EMF equation of alternator. Thank you.